Hello, and welcome to Project Obsidian. This station is a cyber threat hunting station. The title of this section is called Sniffing Compromise, Hunting for Bloodhound, presented by me, CerealKiller. A little bit about myself. I've been in the security space for about 5 years. I also enjoy playing video games. I enjoy music. I used to love playing live as a DJ. When I'm not doing those things, I am trying to expand my knowledge of all things security, technology, and life in general. In this section, we will learn briefly about threat hunting, or at least an intro into threat hunting. What is Bloodhound? What it does, what it's used for. We'll also be talking about what the ingester is, what it actually does, when the ingesters ran, a brief overview of the UI, not too much, but yeah. We will also be covering how to hunt for Bloodhound, right? And we'll be using network and host level activity to detect this. So threat hunting, what is it? To me, threat hunting is a practice to proactively look and search and understand what you know and what you don't know within an environment, right? You can use threat hunting to confirm that Windows event logs are actually going to your SIEM, right? That would be an unknown. And unknown would be if somebody within your organization had to turn off the shipping of those logs from Windows to your SIEM, right? And you could use threat hunting to discover that. Or if some of the data is misconfigured, corrupted, any of that kind of stuff. Now that we have a short understanding of what threat hunting is, let's talk about Bloodhound. So Bloodhound is a tool used by many security professionals. They're either on the red team or blue team, but it's also used by adversaries. And the reason for this is because Bloodhound gives a great view of the data when it comes to Windows Active Directory. So it's used for enumeration. It gives you access to information like user groups, workstations, servers that are connected to a Windows AD. It also gives you the ability to query this data with its own query language. So Bloodhound is comprised of two components. The UI, or the GUI, the graphic user interface, which this is usually installed on workstations that are ingesting the data. And this is what it looks like. There's a search at the top left. Each thing within an AD is represented as a node. So here we have 3 user nodes on the left-hand side and a group node on the right-hand side. The lines between them is a relationship between them. So you can query for misconfigurations and relationships between different nodes or different OUs, users, servers, so on and so forth. And you can see this picture on the Bloodhound Read the Docs website. The other part is the ingester or the collector, right? So the ingester, the collector, right? It's usually binary or a script. There's like 3 methods of ingesting. The ones that we are currently looking at is the .exe, which is called sharphound, and the PowerShell script, which is sharphound.ps1. The ingester or collector, what it does, it queries domain controllers via LDAP-S, and it's trying to gather information using Windows APIs for user information, security groups, domain joined workstations and servers. The other thing that it does is that it connects to workstations that are online, and it talks to them via RPC, via SMB. And what it's trying to collect is user sessions, logged on users, more workstation information, and local group members. Now that we have a good understanding of what Bloodhound is and the various parts of it and the components of it, let's talk about how it's used or when it's used. Usually it's used by adversaries after a compromise has happened or once they get into a network. Let's say they get access to a server or workstation. This is when they would run Bloodhound to see if they can find a misconfiguration, an overly permissive security group, or a user that has access to a lot, any of those things. The other way that it's used is by security teams. And they do an audit of a Windows AD, or at least some of the organizations I've worked with, that's what they do. But for us, what this means is that if we are hunting for Bloodhound, we are assuming that the adversary has gotten it, right? And we want to know if they have ran Bloodhound, or if they haven't, how can we tell if they will, right? Like, well, what kind of detections we can set up there. So now that we've talked about Bloodhound and how it's being used and a little bit about what threat hunting is, I say let's go hunt. Let's go find this within the data set that we have. I didn't want to use too many slides, so this is going to be a somewhat pre-recorded live demo. So let's go hunting. Okay. We are now inside my virtual machine that has access to our Splunk instance that's containing the data that we're going to be working with today. So on the top left hand side under apps, we have search and reporting. This is where we want to go so that we can conduct searches. Well, the first thing we want to know is what kind of indexes or data we're working with. So we're going to go over here and go to date range. We're going to choose between, and we're going to select February 18th through the 20th. And I'm doing this because this is when we ran our simulation. The simulation is just an activity when somebody within your organization or a third party comes in and pretends that they are an adversary. It's a good way to test your detections and your threat hunting. Alrighty, so let's start with what I'm entering here is a query that I found online to get all the indexes that exist within this time frame. Awesome. So here we see we have HMail, main, OS query, PCAPS, summary, Circata, syslog, sysmon, Velociraptor, win event logs, and Zeek. Awesome. Alrighty. Now that we know what kind of data we have available to us, let's start with a simple query. Let's start with Bloodhound. Okay, so we get a singular hit. This happened on Saturday, February 19th. But if we look at this, this is not well parsed. So there's probably a problem here, right? Okay, so we see that this is unparsed, right? Well, I always like to take notes on everything that I do, especially for threat hunting. Like, notes are very important. So let's go over here to Visual Studio Code and let's start a note. I like to use Markdown for everything that I do. You choose your preferred method. So what did we do? We ran Bloodhound. And the result is an unparsed document. But we do get a host name, right? So let's save that. We do get a host name. RDP0. Cool. Well, now that we have this, well, usually when Bloodhound is run, it's either ran in memory or it's ran from disk. In order to run it from disk or from memory, we need to download something. So, I remember back when we did the other search that we had sysmon and WinEvent logs. I know from working with sysmon and WinEvent logs that sysmon has an event ID for file creation. So let's see if we can find that. First, let's figure out what do we have inside those indexes. So here I put index in, so this makes it an array that it's searching in both. Right. Another way that you could do this is by using OR. So you could do index equals sysmon or capital OR. Index equals when event logs. This will give us the same results. I just prefer the other way that I did it. It's much cleaner to read. Alrighty, so looking at these events, we see that this is a file created. It has these fields, a directory, an extension, a name, a path. This seems useful for what we're trying to get. But this, I don't want to keep looking through every single event like this. So let's see if we can come up with another query that will help us and clear things up a bit. Alrighty, so we can do index in, and then let's do stats. Let's get a count by win log.event ID. So this will give us the count, like how many times a certain Windows event log ID has happened during this time period. Okay, so we get a bunch of them here. With event ID 1, we got 3,000. Oh, nope, 5,000. Keeps going up. So we'll give this a little bit for it to finish. Alrighty, so we see a lot of different Windows event IDs here. But I specifically said sysmon, right? So let's see if we can figure out sysmon file create event ID. Oh, here we go. So it looks like sysmon event ID 11 is for file create. Okay, taking this, let's go and put this into our search. Right? All right. So we want to, so we can append this to the top of our search. So winlog.event underscore ID equals 11. That means we're looking specifically for Windows sysmon event ID 11. Let's see how many we get. Okay, looks like we get around 8,000 events. 7,000, I know, 77,000 events. Okay, that's quite a bit of events. Okay, we can look at the events over here. It's the same. We got file information. Let's see if we can make this into a pretty table that will help us identify a bit more as what's going on here. Okay, let's add the table. So what things do we want? So table, and I'm pretty curious about this information. So let's do host.name. Let's see where it lives. File.name. File.path. I think that's good for now to start. Okay, we get a bunch of events. A lot of DAT files. Looks like some sort of health check. That's cool. Alrighty, well, we see that there is a file.extension. So maybe we can use that to our benefit. Right, we're just looking for .exes and .ps1s, which is PowerShell scripts. So let's go back up here and let's add file.extension. Right, let's do the same thing. Let's do in exe and ps1. Right. Let's see. Alrighty, that's much better. We got 4,000 events, a little bit over. We get a bunch of information on exes, a lot of temp files, probably updates, who knows. But this is a much smaller data set that we can work with. Let's see if we can continue scoping down our search and seeing if we can figure something out. If you remember, we did take notes. So let's see if we can use this to help us with our search. Well, we have this host name that we know showed a singular log that had Bloodhound in it. So why not just take this and put it in our search. All right. I think this is the place that we suspect. Let's see. Okay. Let me get some results. 700, 730-ish. Not bad. But still looking at all this, nothing really pops out. And we can go through all this, or we can, look for file name. And we can do something like bloodhound.exe. Oh, but is it bloodhound.exe? I don't think so. Let's go look at the GitHub. Let's go see what the collector is actually called. So we have these collectors here. Oh, it's Sharphound. So let's copy that. Let's go over here. Replace this. Let's see if we get any results. No. The other one is .ps1. Let's give that a shot. Doesn't look like it. Maybe it's case sensitive or insensitive. Who knows? Let's try it. Try it all. Okay. So looking at this, it doesn't seem like Sharphound was downloaded or created on the system. But we do get a lot of different events here, right? So, myself being a detection engineer, something that I would set up here is, hey, I want to know if and when sharphound.exe or sharphound.ps1 is being ran within my environment. So we could do something like this, where we have this type of search, maybe not this host name, right? But we would look for file.name in, right? We can do sharphound.exe, sharphound.ps1, and then if this ever returns a result, hey, notify me. So, since this is a pretty good search, I'm going to put this over here in my notes for file creation. Because this is markdown, I'm going to do this, right? So this gave us no result. Either we did not log this, or Bloodhound / sharp was ran from memory, right? Okay, so what do we do now? Well, if we think back to our first query, when we were looking at indexes, we did have pcaps, Zeek, an OS query, right? So maybe sharphound will work there. So let's just do a broader search. Oh, look at this. So this is coming from Windows PowerShell logging. Awesome. That's another way we can search for this, right? Windows PowerShell logging. Let's see if some things are being run. Here's another event that doesn't look parsed, but looks like most of this is, yeah, executing a remote command from the same host name. This is coming from WinEventLogs, right? Yep, WinEventLogs. WinLog event 4104. Interesting. Okay, so index equals WinEventLogs. Logs, and then what is the event? When event ID 4104. Okay. Get 1,000 results from this. Okay. This is cool. But we're looking specifically for sharphound. This is doesn't like maybe this. There's a couple places where this sharphound's showing up. So this is another way that we can set up a detection for this, right? So we can do there's not much. We get the scripts, but it's not necessarily parsed. And there's no file name to this either. So I think this would be a broader detection. The other place that we can look for is in Zeek network telemetry or network index. So let's see what's going on with Zeek. Okay, get a bunch of information. Well, if we remember back to my slides, we know that Bloodhound uses SMB and LDAP-S, right? I know that SMB uses port 445 and 139. So let's see if we can find any of this. Okay, this search shows us about 11,000 events. That's quite a bit. So it looks like we have a pretty big spike here. So let's see if we can manipulate this data so we can understand it a bit better. I'm going to do stats, count, and now we're going to do values. And this is just so that we are looking for a specific count of a certain value. We're going to do id.response port by host name. And I'm getting this from this right here. Okay, so let's see. Oh, awesome. This is pretty indicative that something's going on with RDP 01. Like 340 counts for using 445. As an RDP host, that's pretty strange, right? Let's see if we can use other stats here. I remember that there was a type. There's an IP address. And there's very different types of source types. These are connections. So let's see what type of source type Zeek has. Source by service. Okay. So there's a bunch of connection. Let's just do by source type actually. Source type. Oop, that didn't work. By source type. Oh, whoops. Sorry about that. Okay, so we have connection history, connection summary, DNS, files, NTLM, SMB mapping. Let's see if we can find the events for this. Okay. So this is for a file server. File open. Okay. Close these out. NTLM. Let's see what this has. Okay, this is connections from workstations to our file server. Oh, this is interesting. So this is RDP talking to workstations. Okay. So maybe we keep this sort type. Let's see if we can do a stats count on values using a host name, right? Let's see, a host name by server DNS computer name. Oh, did I misspell something? Computer name. Oh, there we go. Awesome. So if we look here, we see that RDP01 has been getting around. Bunch of events going to workstation 1, 2, 3, so on and so forth. It looks like mostly all of them. That's interesting. So I think this is another query we should probably save in our notes. This looks like interesting. SMB connections by host. Right. And to me, like something like this is something that will also try and convert into a detection, right? Especially when, or I guess it depends on your environment, a RDP host or a jump host is making these types of connections. Like I expect something like files to have this many connections from various different hosts, but all these hosts to have connections from an RDP host when it's not an SMB server or something, that's sort of abnormal. So that's probably a good way to detect this, right? Even this could even cover not Bloodhound. This could cover manual enumeration from an attacker if they are trying to be stealthy and they don't want to trigger downloading Bloodhound. They could do a manual enumeration, but we could still see this on the network side, all these types of connections. Well, I think I have shown different ways that we can be hunting for Bloodhound and or other Windows enumeration. This has been pretty interesting. But now that I think we have concluded that RDP host 01 has been compromised and has been doing this type of telemetry, we would have the forensics team run forensics on it, or seeing what other kind of things we can hunt for. And to close this out, I think we should cover the threat hunting template. So this is something that I like to use and other members of the Blue Team Village like to use when it comes to threat hunting. And it's pretty basic. Yeah. There's a playbook title, the MITRE tactic, the MITRE sub-technique, the hypothesis. We didn't really go into detail about hypothesis, but there are other recordings and other stations, or within this station, that will go over hypothesis. And then there is a proposed detection query, simulation details if there are any, the limitations and observation notes from what we conducted, right? Like we did find certain things like certain logs not being parsed or not being able to find certain logs. Yeah. And then our conclusion, right? Our findings of like what we found when we were going through this. So we can fill this out, right? We're gonna title this Bloodhound being run within our environment. I don't think I spelled that correctly. So the miter tactic, right? So we can do a quick search. Miter. Right, so miter is a framework for different techniques and attack paths, and there are plenty of resources out there on understanding what miter is. But what we need from here is, well, what tactic is going on here, right? So there's a bunch of them here. Usually the one I go for is this one, which is account discovery, because that's the best use case, at least in my eyes, for this. So there is this, which is just account discovery. And local count discovery to be specific, at least with the sub technique. Our hypothesis in a event with a system that's been compromised, attackers will use Bloodhound. Enumerate that environment. Awesome. So, what is our proposed detection query? At least for on the network side, we'd have something like this. All right. Or is this actually? Maybe we can switch this around. Do this and then do a host name here. Yes, right. There you go. This is much nicer. So let's take this, or actually, let's do this. Where count is above, and what's like, the issue is like when it comes to files, right? Like we're gonna get some false positives here, but anything, let's see, above 100. Like we want to get alerted on. So let's take this. Let's put this detection query here. You know me, I like markdown. There are no simulation details here. What are some observations and limitations? So a limitation that we add here is some logs were parsed incorrectly. Parsed incorrectly. We did not see valid creation for the Bloodhound binaries, right? I don't think that's spelled correctly. It is. So, what else can we say that we observed? I think that covers it mostly. As to findings, well, we found that RDP host 01 has been making various connections to other workstations, right? This is abnormal for this type of workstation. Right, and that's it. That's our threat hunting template filled out with everything needed. And I want to say thank you for joining me on this journey. And if you feel like continuing this conversation, please join us on the Blue Team Village Discord. Thank you.